Okay, so Victoria got the answer correct, so I'm going to show you how she probably got that answer. Um, you have to do some algebraic substitution here. Now, we just discussed how this is the sum of the torques. Well, there's only one torque that's acting on this disk. So the equation for torque is the force that makes the torque times R, and then times the angle that it makes. Equals. And then moment of inertia, you had to understand that this is a disk, right? So then you had to use the right moment of inertia formula. So the moment of inertia for a solid disk is 1/2 m r squared, and then angular acceleration. Okay. So something kind of magical happens here that we should be able to say. Does anybody know what's happening with this formula? There's something that we can eliminate. Very good job. Good job, Elude. R can go away. So this R is gone. So right here, this R is gone. And then there's two R's here, so we're just going to get rid of the squared. The symbol for moment of inertia, Victoria, is I, capital I, to be exact. Okay, let's clean it up. So F sine of the angle that it's applied equals 1/2 m, just one r, and then alpha. Okay, so remember, we're solving for angular acceleration, which is this variable. So we can do some algebra to get angular acceleration by itself. So that's F sine beta. Move the 1/2 over, so that makes this a 2. And then divided by m r. That's a very pretty R, Miss Witecki. Okay, so we weren't really given an angle here, and that might have messed you guys up. So I'm gonna make this big assumption that if we're not given an angle, then the angle is probably perpendicular to 90. No, Victoria, it's not squared because we eliminated it on the other side. It's kind of like everyone brought mass to the party, except everybody brought radius to the party. Just one radius, though. That's why we had to get rid of the squared. But you got the right answer because the math will still work out. So 2, and I'm going to substitute my numbers. Force was 5 newtons sine of 90. Okay, because we weren't given an angle, so we'll just say that it was 90. And then the mass times the radius, which was 2 meters. And then that'll give you, when you do the math, 1.25 radians. Oh my goodness. Per second squared. I bought myself a really nice pen. It's just coming in the mail later this week, so it'll get better. Okay, any questions on how we did that? Puppy, get out from under there. Thank you. Any questions? Okay. All right, so if you look at the AP Physics rotational motion, there's still plenty of things that we have to go over in this unit. And, some of you have not finished the Schoology Week 16 yet either, so I'm still kind of hesitating to teach new material. And I really am trying to take it slower since it's possible that our AP exam will be um, postponed, not canceled, postponed. They're not going to cancel it. So postponed meaning the end of May or even into June. I'll let you guys know. But we can spend this time preparing and working together to figure out what we're going to do here. I mean, this is a new situation for all of us. So thank you. I know today was rough with some um, video issues and I can't hear um, kind of thing, but we'll figure it out. Victoria, if it's moving counterclockwise, shouldn't it be negative? Well, we calculated for angular acceleration. So if it was negative angular acceleration, that means it's slowing down. So if we were calculating how do I want to explain that? If we were calculating maybe velocity, it might have become negative. Yeah, that's a good question, but I think in this case we don't have to worry about the direction. Maybe when we do some more examples, Victoria, it'll become more obvious to us when we need to keep direction um, considered. But that's a really great question. Stay tuned because I think that idea is going to come up again. Yes, the problems are due Friday, but again, I'm going to state this and I hope I'm recording. I'm not going to say anything is due. I have not gotten permission to grade anything. I don't know what's going to be acceptable when it comes to grading or holding anybody accountable. All I can tell you right now is what I think is going to happen. There were a few assignments that I assigned before spring break. I might be able to hold you accountable for those. But right now, all we're doing here is just enrichment activities. So um, if, I have that meeting with Mr. Ibarra and he says, Miss Wadzicki, do your thing, then, there's going to be the regular assignments that we're used to, meaning problem sets, AP classroom, Schoology folders, and, it's going to be the same stuff that we were always doing. Um, so I don't think much is going to change except we don't get to be face to face in terms of my class. We're going to use the same resources. Okay, well, I'm going to get off, go live because I know there's some people wanting to ask questions or do questions together. Um, don't be afraid to call me and video chat. Um, I'll be on here until 3, maybe even past that. Okay, and don't be afraid to chat with each other and do the problems as well. That's why we're on here. Okay, you guys take care. I I do miss y'all. I hope everything's okay. Um, and let me know if anything changes for you, okay? All right, bye.